Hello, everybody. Good morning, good afternoon, good day. I hope you are all safe and doing great and coping with our online classes. Today, we are going to move on to another topic in earth science. In fact, we are already on MELC number 4, which is on rocks. And today, as we talk about rocks, I'm pretty sure that you have already a lot of preconceptions or backgrounds, no, in terms of rocks, as you may have had some learnings already in your elementary years, and of course in your junior high school years, I'm sure. And today, I hope I would be able to um, give more new inputs, no, in terms of rocks concepts. And my name, by the way, is Sir Joshua, and I hope um, you will be also asking, no, your teachers some questions with respect to rocks after this discussion. And there's actually an activity as well after this short online lecture. So please bear with me, and I invite you to take down some notes as I go along. So in the picture, I'm sure you're also familiar with that. That is actually the Taj Mahal that is found in India. No, that building is actually quite. That's not quite, but it's really an old building that I think was erected somewhere in the 1680s. No, by an emperor as a mausoleum for his wife. So that Taj Mahal there is actually um, built in marble. No, so Taj Mahal is a marble, and marble is actually a metamorphic rock. Though it is composed of different kinds of marble, but it is said to be 100% marble. So the Taj Mahal is actually one of the, I think, heritage and treasures, one of the treasures of the world, no, by UNESCO. And I think this could be one of the biggest erected metamorphic rock building, no, here in our planet. And of course, this has become a tourist attraction as well, and of course part of the culture, no, and history of the people of India. So rocks. We define rocks as a natural substance composed of solid crystals of different minerals that have been fused together into a solid lamp. Now, in the previous discussion with your teacher, it has been established that minerals are the ones that actually compose, no, your rocks. So if you have lots of minerals that have been fused together, we create a rock. Now, these are the types of rocks. We have the igneous rocks, the sedimentary rocks, and the metamorphic rocks. Let's discuss each of these rock accordingly. Now, igneous rock is sometimes called as the magmatic rock because these rocks are formed when molten material from within the earth called magma cools down and solidifies, forming crystals. And they are thus characterized by interlocking crystalline texture. And of course, we know that when this molten material is being ejected outside the volcanic system, we refer this already as lava. And when this lava cools down, we actually create the igneous rock as well. Now, there are two types of igneous rocks according to where it is formed. If your igneous rocks are formed from magma that cools slowly and at the same time are coarse-grained, we refer to them as intrusive igneous rocks. Now, if your igneous rocks cooled quickly and resulted into fine-grained and it lacked some crystal growth, and they actually formed outside the volcanic system, we actually call this as the extrusive igneous rocks. So the classification of your igneous rocks depend on where it formed. If it formed inside your volcanic system, then we can say that it's intrusive. Otherwise, it is extrusive. Moreover, we have to take note also to the grain, no, that each type of igneous rock possesses. So if it is extrusive, it is said to be fine-grained, and if it is intrusive, it is said to be coarse-grained, as you can also see in the picture. Moreover, we can also classify igneous rocks according to their texture, aside from where they were formed. You can have glassy igneous rocks. You can have aphanitic, meaning to say there are no visible crystals. It could also be phaineritic, meaning to say there are visible crystals. And it could be porphyritic, meaning to say there are some visible and some not visible crystals in your igneous rocks. Now, the crystal size of your igneous rocks are also used to classify them. Crystals form as the rock cools, and the crystal size can tell us a lot about its cooling history. Geologists would conclude that the larger the crystals, the slower it cooled. Again, the larger the crystals, the slower it cooled. Your glassy igneous rocks have no crystal structure and probably formed by very rapid cooling, such as on the surface of a lava or when a lava enters the water. Because as established earlier, the larger the crystals, the slower it cooled. So since your glassy igneous rocks have no crystal structure, then it underwent most probably a very rapid cooling process. Your aphanitic rocks have no visible crystals and probably formed by fast cooling above ground. So on the pictures, you can see that there is actually no visible crystals at all. Your phaineritic rocks have visible crystals, as also shown in the images, and these are shown, or these are formed by slow cooling below the ground. Your porphyritic rocks, on the other hand, have both visible and non-visible crystals, and they are probably formed by two different cooling events. So I think that's a justification why there are some that are visible, and there are also some parts of it that its crystals are not visible. Meaning to say, this rock, probably had an experience, no, of having two different cooling events. Your dark igneous rocks are formed from basaltic or mafic magma. When we say mafic, it means that it contains a lot of magnesium and iron. And the magma that forms these rocks is usually very hot. It's around 1,000 degrees Celsius, and its viscosity is the same as a ketchup, no? So you can imagine that. Meanwhile, your light-colored igneous rocks are formed from silicic, meaning to say they are very rich in silica content, or felsic magmas. The magmas that form these rocks is usually more cool compared to your dark-colored magma, which is lower than 850 degrees Celsius, but that is still relatively hot, and more viscous, about the viscosity of a peanut butter. So if we compare your dark and light igneous rocks, there is actually a difference, no, with respect to the temperature that they actually took to cool down. In terms of structures and formations seen in igneous rock, they actually include your hexagonal columnar joints, your pahoehoe lava flows. Pahoehoe is actually a Hawaiian term, no, which later on will be discussed also further. They actually form your dikes, your sills, your batholiths, your pillow basalts, and of course your volcanoes. These are the common types of igneous rocks. You have your rhyolite, your andesite, your basalt, your granite, diorite, and your gabbro. So some of the images are actually also flashed there on screen. As you can see, some are coarse grained, some have fine grains, and some also have very visible crystals. No? Now, this is the Igneous Rock chart. I will not comprehensively discuss this one, but we can actually describe our igneous rocks, as you can see, in terms of color, whether it's light, whether it's dark, and in terms also of the mineral content, which is percent by volume, and the silica content, which is percent by weight. So as you can see, there is a relationship, no, with regards to the mineral content, to against its color, and of course there's also a relationship between its silica content against its color. And of course, there are also some interpretations that we can do with respect to the comparisons, no, between mineral content versus the silica content. I'll proceed now to the sedimentary rocks, and these rocks are actually formed by deposition and subsequent cementation of mineral or organic particles in the floor of oceans or other bodies of water at the Earth's surface. So the process actually takes four major steps. So the first step is we take I'll take everybody to the first step, which is, you know, at the land. You have eroded sediments end up in the water and begin to settle, sedimentation. So when we talk about sediments, these sediments could also be some pieces of very small pieces of rock particles, no, that will be eroded down to any body of water. And through certain periods of time, they will try to settle down, of course, due to gravity and density. And we call that process as sedimentation. Subsequently, through time, there will be more layers, there will be more sediments that will pile up, and they actually press down the lower layers. And we call this phenomenon as your compaction. Third, there will be more layers, and these pile of layers, we refer to them as strata. They will further compact, and further compaction will lead to what we call cementation. No? And cementation means there will be salt crystals that will glue the layers together. And there will be a rock mass formed, and that rock is actually your sedimentary rock. So looking at the process of sedimentation, compaction, and finally cementation, thus the formation of sedimentary rocks, this actually take thousands of years, or even hundred thousands of years, or it could be millions of years. Your sedimentary rocks are likely to form in areas like your deltas, like your beaches, in rivers, in glaciers, in sand dunes, shallow seas, and they can also form in deep oceans. Okay, so there are two groups, no, in sedimentary rocks. You have the clastic rocks, and you have the chemically or the biochemically formed rocks. So let's discuss each. For the sedimentary rocks that are clastic, they are made of pieces of other rocks that have been weathered and eroded. So this is the typical ones that these sediments have been eroded and weathered after periods of time, no? And they are actually grouped based on the size of grain that they are made from. So of course, since this is like you have pieces of rocks glued together, they will actually vary in terms of size. Now, very small particles make up mud rock. Okay, so there's a mud rock there. Medium-sized particles make up your sandstone, and your large particles make up conglomerates. No? So the type of rock, the type of sedimentary rock that is actually is being newly created also depends on what size of particles actually make them up. No, so if you have small, you have medium, and you have your large. So for small, you can create mud rock. For medium, sandstone. For large, you create your conglomerates. Now, the second type of sedimentary rocks, which we call chemically processed, we call them also as biochemical rocks, no? Meaning to say these are formed from living things, or these are formed by chemical precipitates, no? And they actually form from lakes or shallow parts of our seas. So examples of these sedimentary rocks that we can refer to as biochemical are shown on screen, no? So we might mistakenly identify these rocks sometimes as shells or what, but these are actually sedimentary rocks, no? From living things like decayed animals, decayed leaves, decayed branches, and through time they have been cemented, compacted, no? And they create chemical precipitates, or we call them sedimentary rocks as well. Now, structures and formations seen in sedimentary rocks include stratification, cross bedding, graded bedding, ripple marks, mud cracks, and fossils. Now, because as I mentioned, it's possible that we can also form rocks now from living plants, or from living animals, no? And even humans. No? These are some of the most common types of sedimentary rocks: your conglomerates, your sandstone, your shale, your limestone, your gypsum, your oolites, and your chert, no, including the black flint and the red jasper. So I will not individually discuss all of this, but if you have the extra time and you're curious enough to get to know all these sedimentary rocks, then you may simply do a simple Google search, and you'll be amazed also by the applications of these rocks, no, in constructions, in beautifications, and others. Let's proceed to the last type, and that is the metamorphic rock. Your metamorphic rock were once igneous or sedimentary rock, but they have been metamorphosed, or they underwent the process of metamorphosis, and that is due to the result of intense heat or pressure within Earth's crust. Or collectively, we call pressure and intense temperature as stress. No? So when you say there is a stress, the rock has been subjected to stress, it actually pertains to intense temperature or intense pressure. So your metamorphic rocks are also classified into two groups. They are the foliated metamorphic rocks and the non-foliated metamorphic rocks. So I think this is very visual, no? For foliated rocks, they form when there's a differential pressure, no, that causes minerals to form in layers. So these rocks will have stripes or planes that will break easily along. Now, it's easy to spot foliated rocks because they will have this what we call stripes, no, that we also see in zebras. However, these stripes don't usually line up with the original bedding planes in sedimentary rocks. So, aside from the stripes that we see, or the cause of these stripes that we see is because of the differentiated pressure, no, the pressure that the stress that this rock received, no, is not actually we consider as equal. No, it experienced different rates of pressure and heat at different parts, no, and of course there could be changing as well with respect to time. So that's why they become foliated rocks. Meanwhile, your non-foliated rocks formed in areas where the pressure from all sides was equal, and therefore there is no linear quality to the rocks. So, meaning to say, in terms of the cooking, or in terms of the metamorphosis that it underwent, by subjecting itself to heat and pressure, it experienced an equal pressure and heat from all of its sides, and that's why you create no linear quality, no, to your rocks, and you cannot see any stripes at all. So the structures and formations seen in metamorphic rocks include the folding, your plastic deformation, stretching, and alternating dark and light layers. So we actually refer to this dark and light layers as your gneissic foliation. Now, these are the some of common types of metamorphic rocks. You have your slate, you have your schist, you have your gneiss, you have your amphibolite, your marble, just like your Taj Mahal, and your quartzite and the metaconglomerate. So in the pictures, you can see there the pictures of gneiss and schist. So these are examples of metamorphic rocks. So for sure, no, these rocks used to be sedimentary or igneous, but they underwent to stress, no, which would mean intense temperature and intense pressure. But of course, then again, this happens over a long period of time. We're not talking about 2 weeks or 3 months or even a year, but we're talking about hundreds of years or even millions of years. This is a chart also with which I won't comprehensively discuss of a metamorphic rocks with respect to the stress that it experiences in terms of temperature and pressure. You have your shale, your slate, your schist, your gneiss, and you have your migmatite. So what it says there is uh, there is an increasing metamorphic grade, no, when there's an increasing temperature and increasing pressure. And then also on the right side, there is this like sort of a map of showing you the original rock, and then it undergo metamorphism or metamorphosis. Um, Metamorphism, from shale to slate, from rhyolite to schist, from granite to gneiss, from basalt to amphibolite, from limestone to marble, your sandstone becoming quartzite, your conglomerate into metaconglomerate. So you can see there igneous rocks or sedimentary rocks becoming metamorphic rocks, no? Via the process what we call metamorphism. I won't really discuss this much because I'm pretty sure you're familiar with the rock cycle. But to sum up my discussion about the three types of rocks, I think it's the rock cycle that we really wrap them up. No, like you start from the igneous rocks. Of course, you have two kinds of igneous rocks. You have the intrusive and the extrusive, and you can also classify them according to the texture. And then these igneous rocks can undergo weathering and they could be eroded, and therefore these sediments can actually be compacted and cemented through time, and therefore you create your sedimentary rocks, of course, in your sand dunes, in your glaciers, in shallow parts of the seas and deep parts of the ocean. And then this sedimentary rock or igneous rock could be subjected to heat and pressure after long periods of time, and you create your metamorphic rock. And then the metamorphic rock, they could be melted again because they could be, converted into molten materials, and then this molten material can then be again become lava, no, as they could be ejected outside the volcanic system, and you create igneous rock, and the cycle continues. So this is actually how these three types of rocks are being interconnected. So let's talk about rocks as natural resources. Now, did you know that each person will use thousands to million pounds of rocks during his or lifetime? So in our discussion in minerals, we said that a person will actually use 3.5 millions of pounds, no, during your lifetime. That's actually literally from womb to tomb, no, as you were born in this world and as we live, no, from this world, and then we die in this world. So that's the amount of rock that we're going to use. Like, for example, the house that you'll be building, the house that your parent built, the house that your grandparents built and their parents as well, so on and so forth, even to the to the earliest rocks that Moses, that Joshua, that Jesus actually used, no? And of course, to arts, to jewelries, to the pencil that you use because there's a graphite in there. In the bathtub that you'd like to relax, the fireplaces to heat up cold countries, the mirror that you always face early in the morning to check if you are cute enough for your crush. And of course, soda cans, your stone walls, your walkways, your cars, of course, your makeup, they do contain minerals. Your gravestone when we die, and countertops, your chalk, the curbs, of course, the medicine, they contain also minerals, electronics, especially we mine some of them, the jets, the glasses, name it. Most of these things actually contain rocks and minerals. And your activity is you're going to get a rock sample, and please wash it properly, no, because they might contain some germs and bacteria. So the full worksheet is attached down below, so you just have to download it. So what we want you to do is try to look for a rock and then wash it properly and then check for its properties. You will be guided by a worksheet. So that will be all. Kindly email your teacher. If I'm your teacher, please email me if you have any question, or you may chat via the Soul chat box. Thank you, everybody. Have a great day.